And then for the homogeneous mixture, you have a single phase. Now the single phase we're referring to whether it's solid or liquid or gas. Okay, you could have a homogeneous mixture in the solid phase. An example would be alloy. Okay. Copper and zinc. You can melt them together, and then once they solidify, you can't really tell which part is copper, which part is zinc. You end up with the brass. Okay, so that's the mixture there, and it's in the single phase, solid phase there. So all portions of sample must have the same composition. That's the key for the homogeneous mixture. Salt water, for that matter. If you dissolve some table salt in water, you can't really tell which part is water, which part is salt. They are all mixed together uniformly. Okay, so homogeneous mixtures have uniform composition because the atoms and molecules that compose them mix together uniformly. Okay, so that's the key to differentiate between the homogeneous mixture and the heterogeneous mixture. Now, we can separate mixtures by using physical method. Now, physical method means there's no chemical reaction, there's no chemical change undergoing when you try to do the separation there. So mixtures are separable because the different components will have different physical or chemical properties there. Now, one thing here is that if you have salt water, if you have salt dissolved in water, if you try to separate the two, one thing you can do is you put that water in a pot, you heat it up. When you heat it up, water will evaporate. When water evaporates, salt is left in the pot. So that's a separation. Evaporation is a physical process. Okay? So different types of techniques can be used to separate mixture there. Or if you have sand and water mixed together, simply by pouring the water out, you can achieve the process of separation. Your textbook actually gives you some examples of physical method separating the mixtures there, filtration being one of them. And to do this, probably many of you do this on a daily basis. In the morning when you brew that fresh cup of coffee, you have the ground coffee beans in a paper cup, you pour hot water on top of it. Whatever is water soluble will dissolve in water and will go through the filter paper. So that's a filtration. You are separating chemicals from the coffee beans. Wow, that may be scary. Think about the term chemical. Yeah, whatever you eat, whatever you drink, those are the chemicals. Those are the matter. The scope of the study, enter the scope of study of chemistry there. So filtration would be one physical method. Another way, if you haven't had any biology classes there, you may have used a centrifuge. When you have a liquid and solid mixture there, the solid particles are very small, and it's hard for you to simply pour the liquid out without pouring the solid out. Well, you put it in a centrifuge. When you have a high-speed spin, then the centrifuge will, after the centrifuge there, the solid will go to one end, and the liquid will stay on top, and you can do the separation there. Okay. Evaporation, we'll just give you that example there. Evaporation, we can use evaporation to separate the mixtures there. Distillation, this is one of the things that you will be doing in organic chemistry labs on a regular basis there. When you have two liquids mixed together, you can use distillation to separate them based on their differences in boiling point. Okay? And extraction, solubility, different. For the compounds in one solution, one solvent versus the other, they have different solubility there, so you can do extractions there. Now, you don't have to know the details about these different processes there right now. When we go through those different type of things, and many of them, we're actually going to use them in the laboratory there. So when we go through the process of the separation of mixture there, we'll tell them, hey, this is one way that we can use to separate the mixture there. So in your textbook there, I'll give you some examples, filtration, distillation. Okay. It all depends on the separation of the mixture, all depends on the differences of the chemical components mixed in there, differences in their physical and chemical property there. So we can actually separate these for the mixture that we have there. We can use different methods to separate them. Okay. And this is a partial list of things that we can do to do the separation. So based on the definition that we talked about, this is something that we want to do as an exercise. So we want you to cross-match different categories of things based on the definition. If you have an 18-karat gold jewelry, would that be an element, a compound, mixture of elements, mixture of compounds, mixture of elements, and compound? Well, you have to understand what is an 18-karat gold jewelry. 18-karat gold means 75% of gold. The other 25% is other metals. The metals exist in the metals exist in the elemental form. Okay, so 18-karat gold jewelry would most likely to be a mixture of elements. What about water solution of sodium chloride?
Mixture of compounds.
Mixture of compound. Water is a compound, sodium chloride is a compound. You mix them together, you end up with a homogeneous mixture. Hydrogen gas.
Element.
Element, pure element. Same atoms combined together chemically. It's a molecule also. Glucose.
Compound.
That's a compound, yeah. 6 carbon, 12 hydrogen, 6 oxygen in there. Air.
Mixture of compounds.
Mixture of compound.
Elements.
It's mainly a mixture of elements. Yeah. Oxygen gas, that's an element. Nitrogen gas, that is 99% of the composition of the air here. 78% of nitrogen, 21% of oxygen. That's what we have in the air. Okay? So mainly, air is a mixture of elements and some compounds. Carbon dioxide. We're putting carbon dioxide into the air every day. You breathe out carbon dioxide. When you drive your car, the burning of the octane, the gasoline, generate water and carbon dioxide. So it's a mixture of element and compounds there. Coca-Cola.
Use of elements and compounds.
No. Yeah, citric acid in there, even nitric phosphoric acid in there. Now, when you take chemistry class, one of the things that I want you to get in the habit of is that whatever you're going to eat, whatever you're going to drink, take a look at the label. I still don't understand why they have phosphoric acid, a fairly strong mineral acid. Why do they mix it in soda? So you're drinking a lot of acid when you're taking the soda there. Coca-Cola, if you can separate them, it's still a commercial secret, I think, and if you can separate the Coca-Cola into its individual components, you may be a very rich person, but that's probably going to get you into legal trouble. Okay. What we want you to do, what we want you to be able to do here is that based on the definition that we talked about so far, we need you to be able to classify different types of matter into different categories of matter. So you need to know the definition in order to do this. Okay. So we will stop here today, and it's about 10:15 there, and you've got about 15 minutes of time. And again, I will talk with Professor Brown. This week we're going to her lab, and we'll try to make some copies. So if you don't have your lab image with you today, it's okay. But by Thursday, we need you to have your lab image. Okay. If you have any questions, remember my door is always open. Canvas, email, or see you in person. Okay.